Hi there. So the reason there's a little shadow here is because that's where the document camera is. I wish I could get that away from you so you didn't have to sort of go into the land of darkness. No, that doesn't really help. Okay, so hi, welcome. This is assignment 70. We're going to do some more solving of log and exponential equations. Okay? Um, but before we do, how about a bell work roll? Will you please condense the following expression? 2 log base A of x plus 1/3 log base A of x minus 2 minus 5 log base A of 2x plus 3. Oh, and don't ask the question what's going to happen when these are different. That's we can look. No, we won't even look. No. I might do something where the exponential bases are different, but these will always be the same for us. So please condense this, and depending how you do, maybe we'll do another one of these. Hey, welcome back. Did you put the powers up first? Log base A of x squared plus log base A of x minus 2 to the 1/3 minus log base A of 2x plus 3 raised to the, what was our power? Our power was 5. Okay. You could put that as a cube root if you want. Some people like to. I'm, though, going to say, oh, look, 2 logs joined with addition. I'm going to multiply these. Oh, look, 2 logs joined with subtraction. I'm going to divide here. So I'm going to end up with 1 log x squared times x minus 2 to the 1/3 on top, and 2x plus 3 to the 5th on the bottom. Remember, all the pluses go on top, all the minuses go on the bottom. Any questions? Yeah, I agree. You need another one. Don't worry, I've got another one here for you. So, what about 5 log base b of x minus 1/2 log base b of 3x minus 4 minus 3 log base b of 5x plus 1. Okay? Please condense that expression. Oh, yeah, you should go off and do that and come back when you're done. So, I hope you brought the powers up first. So we've got log base b of x minus x to the 5th, and we've got log base b 3x minus 4 to the 1/2, and then finally minus log base b 5x plus 1 raised to the 3rd. All right, so can I just say Mr. Doty is funny? These 2 minuses tell me that they're going to be in the denominator when I combine these 3 logs. This is a positive log, so it goes on top, and then I have 3x minus 4 to the 1/2 times 5x plus 1 to the 3rd. Ta-da, that's my log. And if you want to turn this into log base b of x to the 5th over square root 3x minus 4 times 5x plus 1 to the 3rd, you're certainly welcome to do that. But this is fine by me. Okay? We've condensed into 1 log. And so I'm a happy camper. All right. Now, let's get on to solving. So, how about this one? Oh yeah, let's start off actually with the ones that, I just didn't get to in the last video. 500 over 100 minus e to the x over 2 equals 20. So I've got this logistic model over here, and I've got this horizontal line. And just sort of thinking in general about it. Here's my logistic model. I'm not sure where 20 is here. I know this is 500, so I'm guessing 20 is down here. But I don't know. Maybe 20 is up here the way I graphed it. What I do see is maybe my answer will be negative, maybe my answer will be positive, but I see only one solution. So I need one solution here. And this isn't about taking the log of both sides at first, nor is it about exponentiating at first. Instead, this feels an awful lot like a problem that we did in the Algebra Basics unit, where we said, look, we have an equation and it has a fraction. Let's multiply everything by that least common denominator on both sides so we can cancel those out. So now I'm looking at 500 equals 20, 100 minus e to the x over 3. Nice. Many students now distribute. I do not distribute. I resist that temptation, and I divide. Because that's going to make all the numbers smaller rather than making some stuff bigger and more complicated. So I end up with 25 equals 100 minus e to the x over 3. Is it 3 or 2? Oh. Looking. It's over 2. That's called a copy mistake. Okay, so I'm going to subtract 100 from both sides. I'm going to get negative 75 equals negative e to the x over 2. Well, no problem. Let's just divide both sides by negative 1. Now what? How can I get this to come down? That's right. You need to take the ln of both sides, and then you can bring this down. So now you'll have ln of 75 equals x over 2. We want to know what x is, so let's multiply both sides by 2. Tink. And so now I've got 2 ln 75 equals x. 2 ln 75 equals x. Of course, you could always power rule this and say ln of 75 squared equals x. Ta-da! Is this a must check? No, that's an exponential thing. I can plug any number I want in there. And I can take the ln of a positive number. So really, no, this is probably fine and sufficient. But I wonder if now you'd like to do one of those, since I did that one. All right, so how about this? 1,000, 1 plus e to the minus 0.5x equals 50. Of course, you could always graph this in y1 and graph this in y2 and do second calculate intersect, but you're going to have some trouble finding that. Zoom standard is not going to be your friend in this problem, because this is y equals 50, and that's 1,000. So, yeah, rather than wasting the time trying to find a good viewing window, let's just solve this algebraically. Though I will say my calculus students often forget on the calculator portion of the test to, graph it by hand, because it saves a lot of algebra, that's for sure. Okay, so e to the 0.5x. Okay, so we're multiplying both sides by this denominator so that we can cancel those out. You are more than welcome to distribute over here. I'm not going to. I'm going to divide by 50 and make my numbers smaller. 20 equals 1 plus e to the 0.5x. If I subtract 1 from both sides, now what? Well, I got to get this down, and that's only going to happen in the presence of a log. So this comes down here. ln of 19 equals 0.5x ln of e. The ln of e is equal to So 1 times 0.5x. 0.5, by the way, is 1/2. So I could multiply both sides by 2 and get 2 ln of 19 equals x. Or I could divide both sides by 1/2, by 0.5. And so ln of 19 over 0.5 could also be x. These are identical. Any one you want is going to be fine with me. Okay? All right. Solving logistic equations. Now, what about our solving? Well, I've got some fabulous problems for you. For example, log base 6 of 2x minus 3 equals log base 6 of 12 minus log base 6 of 3. And the first thing I want to say about this problem is that students often do this, and that's wrong. How do I know that's wrong? Well, I'll show you in a minute. So here we've got 2x minus 3, and over here I have 12, and over here I have 3. Yeah? And so that's going to be 2x minus 3 equals 9, and 2x equals 12, and x equals 6. And I feel pretty good about that. I plug a 6 in here. 2 times 6 is 12, minus 3 is 9. Okay, but wait a second, because if I'm checking this, I don't want to just put it in here and make sure I'm not taking the log of negative or 0, but I want to see what it looks like compared to what's on the other side. And I'm not sure what this is equal to. I mean, I could figure it out if I pulled out a calculator. If I pulled out an old calculator, I'd have to use the change of base formula, which I'm sure you haven't forgotten by now, but you might need it. So let's say that when we put in that 6 here, I get log base 6 of 9. Do I get log base 6 of 9 here? Wait a second. I thought when I had 2 logs joined with subtraction that was going to be log base 6 of 12 over 3, right? Wasn't this our quotient property? Where I have 2 logs joined by a minus, I can combine them to 1. And then doesn't that mean that this is going to be log base 6 of 4? Yeah, I'm sorry. Log base 6 of 4 and log base 6 of 9 are not equal to each other. So this was wrong. When I exponentiated with 6 everywhere, that doesn't work. It's the same thing as the student who wants to do this. X equals 3 plus square root of x, and they want to square everything like that. Yeah, no, that's not gonna work. Don't do that. Oh, this one has low battery? Yes, it does have low battery. Okay. Excuse me a second. My Wi-Fi node is my phone right now, and it's running out of power. Ooh, I've already, there we go. Okay, so yeah, can't do it to each piece. Have to condense first before exponentiating. Condense before exponentiating. No problem, I can condense these. Log base 6, 2x minus 3 equals log base 6 of 12 over 3. So 12 over 3, yeah, that's 4. And then I exponentiate, and I end up canceling these. 2x minus 3 equals 4. 2x equals 7. X equals 7 halves. If I plug 7 halves in here, this 2 and the halves 2 cancels, and I have 7 minus 3 is 4. And what did we have on the other side? We had log base 6 of 4. So that works great. Okay? Okay. Yeah, you have to condense before you exponentiate. So where are we off to next? How about 2 log base 3 of x equals 3 log base 3 of 5? How can we do this one? Well, power rule has to come first. Log base 3 of x squared equals log base 3 of 5 to the third. Okay, so I exponentiate with 3. I get x squared equals 5 times 5 times 5. And don't forget to take the square root of both sides. Plus or minus. Okay. If I plug a positive square root of 125 there, yeah, no worries. I can take the log of positive 5 root 5. But if I plug in a negative, no, can't take the log of a negative. So that doesn't work. So I only get that one answer. Okay? Next. ln x, minus 4 minus x plus ln of 3 equals ln of 2 minus x. Can I just exponentiate with e everywhere? No! So what am I going to do instead? That's right, I'm going to condense over here. I'm going to turn this into ln of 3 times minus 4 minus x. Now, you might want to distribute here, and I would do that. Negative 12 minus 3x equals ln 2 minus x. What can I use to get rid of these ln's so I can have access to these x's? I need to exponentiate. I know to use e because this is log base e. So e raised to the power of log base e. Yep, they're going to be inverses and they're going to cancel. So minus 12 minus 3x equals 2 minus x. I'm going to add 3x to both sides. I'm going to subtract 2 from both sides. Get negative 14 equals 2x, or x equals negative 7. Now again, just because this value is negative doesn't mean I throw it away. I have to plug back in. Minus 4 minus a minus 7. Well, minus a minus is plus. Minus 4 plus, it's going to be ln of 3. Plus another ln of 3. And over here, if I plug in a minus 7, 2 minus a minus 7 is 2 plus 7, or 9. So that's going to be ln of 9. Are these things equal? Well, let's see. One of them plus one of them makes 2 of them. And power rule, which is, yep, same. It's all good. Okie doke. Next. How about this one? ln of x plus ln x minus 2 equals 1/2 ln of 9. Okay, give it a try. Come back when you're done. I can't wait to talk about it. Oh, you're back already? 2 logs joined with addition means I can write this as 1 log. A power. Let's kick it up. ln of 9 to the 1/2. Okay, so we exponentiate with e. Tink, tink. I get x squared minus 2x equals, yeah. So I didn't take the square root of both sides. So this isn't going to be the square root of 9 plus or minus the square root of 9. It's just going to be the square root of 9, 3. So I've got x squared minus 2x minus 3 equals 0. X minus 3, x plus 1, x equals 3, x equals negative 1. Go back to your original. Plug these in. 3. Sure, ln of 3. 3 minus 2, 1. ln of 1. No problem. ln of 1 is 0. 0 plus the ln of 3. Well, yeah, we just said that was going to be 3 in there. And so I have the ln of 3 and the ln of 3. So this one works. What about negative 1? And I plug in those negative 1s. I'm going to be taking the ln of negative 3. I'm going to be taking the ln of negative 1. And ln says no, thank you. So there's only one solution to this problem. I can't wait to see what's next. How about this one? Log base 4 of, where'd you go? There it is. Log base 4 of x plus 5 plus log base, what? Sorry, 6. X plus 5 plus log base 6 of x equals 2. All right, please solve this equation. Remember, you cannot do that. Okay, come back when you're done. Okay, so I've got 2 logs connected with a plus. That means I can write this as 1 log, and these arguments are multiplied together. Now what? Exponentiate. These cancel, leaving me x squared plus 5x. This is no cancel. This is 6 to the 2nd power. This is 36. So x squared plus 5x. Let's subtract 36 from both sides. And now we can factor as x plus 9, x minus 4 equals 0. My solutions then, negative 9 and positive 4. Well, if I plug in a positive 4 here, I could do that. 4 plus 5, 9. I could take the log of that. What about negative 9? Nope. Okay. Okay. Log base 3 of x plus 3 plus log base 3 x plus 5 equals 1. Go for it. Okay. So I hope we condensed to 1 log first. Now what? Well, I got to get rid of that log. What gets rid of a log? An exponential. I better exponentiate. These cancel. Over here, I'm left with x squared plus 8x plus 15. And over here, 3 to the 1 is 3. Yeah, so I'm solving a quadratic. I want everything on one side, so this is equal to 0. And then I can factor x plus 2, x plus 6 equals 0. So my solution should be negative 2 and negative 6. Well, if I plug a negative 2 in here, negative 2 plus 3 is 1. I can do the log of 1. And if I plug a negative 2 in here, negative 2 plus 5 is 3. Then I can do log base 3 of 3. That works fine. So this works. What about that one? Negative 6 plus 3 is negative 3. No, I can't take the log of negative 3. So I only get one solution. Okay? Nobody is going to remind you on any tests whether you've got a must-check situation or not. Right now, we have 4 must-checks. Remember, 1, you squared both sides. Whenever you square both sides of an equation, not square root, squaring both sides of an equation, that's a must-check. 2, absolute value equals some x stuff. Yeah, that's a must-check. 3, denominator can't equal 0. Whenever I have a rational function, I have to check to make sure that my equation didn't give me a number that's going to turn the denominator into 0. If it did, yeah, I got to throw it away. 4, log equations. When I start off with Not the equation where I take the log of both sides, but just where I have logs from the start, like the last few problems. These are all must checks. Okay, please make sure you must check them. Next, how about this one? ln of x equals 1 minus ln of x plus 2. This is an interesting problem because students want to condense here, but they only see this. There are some students who say, 1, well, that's going to be the ln of e. And they go backwards to what this was as a log before we simplified it. And then they do ln e over x plus 2 equals ln of x, and then they exponentiate. They get x equals e over x plus 2. They multiply both sides by x plus 2. E. X squared plus 2x equals e. Well, since that's an x squared, I better subtract e from both sides. Now, I can't factor that. So I'm going to have to do quadratic formula on this. Ew, I don't want to do quadratic formula. Yeah, but yeah, we're going to. I've got a equals 1, b equals 2, c equals minus e. So x equals, it's not x, is it? Yes, it is x. X equals negative b plus and minus square root of b squared minus 4ac all over 2a. So what happens here? Well, we've got negative 2 plus and minus square root of 4 minus 4e over 2. Now, I could factor here. And if I did, minus 2 plus or minus square root 4, 1 minus e over 2. I could have something like this. And then I could think about this as negative 2 plus or minus square root of 4 times square root of 1 minus e over 2. Okay. And I'd want to do that because the square root of 4 is 2. And now look at all the 2's. I can pull a 2 out of the top. Negative 1 plus or minus square root 1 minus e over 2. Tink. And that's my answer. Or is it? So there's 2 solutions, right? And I'm supposed to plug these back in and make sure both of them work. Remember my original, whoa. Yeah, minus 4ac. Negative times negative, that's a positive. Why didn't you say something? I almost missed that. Okay, so here we go. Yeah, how am I going to check this? Seems pretty horrible. So this is a positive number. Okay. Negative 1 minus this number. Now, I know this number is bigger than 1 because the square root of 1 is 1. Square root of 1 plus some stuff is going to be bigger than 1. So when I do negative 1 plus 1, I get a positive answer. But if I do negative 1 minus the square root of a little more than 1, then that's going to be negative. And let's see what we were originally plugging this into. Do you remember what we used originally here? We had the ln of x equals 1 minus ln x plus 2. Okay, so I'm plugging in x equals negative 1 plus square root 1 minus e. I know this to be a positive number. I plug it in there. All right, I'm taking the log of a positive number. That's no problem. If this was positive and I added 2 more to it, then that's going to be positive as well. So I feel pretty confident about this version. But this version, minus, that's a negative number. And that's not going to work so well when I put my answer in there. So I'm only getting one solution here. The negative solution doesn't work, only the positive. All right, now most students don't do that. They don't see this as the ln of e. What they do is they add this to both sides. And so now I've got ln of x plus ln of x plus 2 equals 1. And I condense these into 1, ln x plus 2, and then I exponentiate. Tink. X squared plus 2x equals e to the 1, or e. And I'm in that nasty place again, where I'm going to have this. And yes, I still have to use the quadratic formula. So very sad. All right, let's go. Actually, I only have like 5 or 6 more problems. Yeah, how about this one? ln of x equals 1 plus ln of x plus 1. Go for it. Come back when you're done. Okay. Yeah, I'm not going to do the ln of e because no one sees that. Instead, I'm going to subtract so that I can get all the ln's on one side. So I've got ln of x minus ln of x plus 1 equals 1. I can't exponentiate yet, but I could condense these and then exponentiate. So now I have x over x plus 1 equals e. Remember, we said when we have fractions in an equation, we want to multiply both sides by the common denominator to clear out the fraction. So what do I have now? On the left-hand side, I have x. On the right-hand side, I have e times x plus 1. I would distribute. I really would distribute there. And so I erase the original problem, and that's sad me. I get x equals ex plus e. Now, I don't see any degrees bigger than 1 here, which means I got to move the x's. This is not e to the x, it's e times x to one side. So I get x minus ex equals e, because these are gone. Here I can factor out an x and be left with 1 minus e equals e. And to get x by itself, I need to divide. So x equals e over 1 minus e. Now, this started off as a log function, ln of x equals 1 plus ln of x plus 1. So, e, remember, is 2.7-ish. 1 minus 2.7-ish is going to be a negative number on the bottom and a positive number on top. Positive divided by negative, that's going to be a negative x value. Can I put that negative x value in there? No, I can't. And so this has no solution. Okay? The math was gentle, but it created an extraneous solution, and therefore, when I check, I see I can't take the ln of a negative number. And since this was the only solution, well, I don't have any solutions here. Graphically, it means these curves never intersect. All right? And think about this for a while. Our first one is ln of x, right? ln of x. So here's ln of x. It's got the point 1, 0, e, 1, and 1 over e, negative 1. The other equation was the ln of x plus 1. Wasn't that the ln of x plus 1, or was it the ln of x minus 1? The ln of x plus 1 plus 1. So moving to the left 1 and up 1. So this point moves over here and moves up 1. So this is now 0, 1. And this is going to move left 1 and up 1. And so I'm going to have this point over here called e minus 1, comma 2. And this moves to the left 1 and up 1. And so I'm here at 1 over e minus 1, comma 0. And so my curve and they don't intersect. Okay. Two more types. First, we've seen this before, e to the 2x minus 5 e to the x plus 6 equals 0. Do you remember doing these before? Okay, so e to the x minus 3, e to the x minus 2. I factor this like a trinomial. I mean, really, this is x squared minus 5x plus 6. It's got that same form. A thing squared, negative 5 times the thing to the first, plus that constant. Well, you would do this as x minus 2, x minus 3, because this is x. So when we go to factor this one, I'm not using x squared, x e to the 2x here and here. I'm using this one, just like I did here. So I've got e to the x minus 3 and e to the x minus 2. We set each of those factors equal to 0. And don't forget to take the ln of both sides so that you can bring down the power. X ln of e is ln of 3. X ln of e is ln of 2. Remember, the ln of e is 1, so x equals ln of 3. ln of e is 1, x equals ln of 2. I get two solutions here. This is an exponential. This is not a must check. You're welcome to plug these in to all those x's, but it's not a must check situation. Our original was not a log. If our original is a log, I definitely want to must check that. All right, will you do this one then? E to the 2x plus e to the x minus 12 equals 0. Please solve that equation. I never understand why you don't pause your video there. It's the perfect time for you to practice. No, really. You know, the reason you walk so comfortably today is because when you were a small person, you practiced all you could this walking thing, and you got better at it. If you don't take the opportunity to do this practice, you're going to be that infant who stops trying to walk and just says, I'm just going to crawl everywhere. Don't be that person. Factor. Okay, so e to the x minus 3 equals 0. E to the x equals 3. I take the ln on both sides. I get x ln of e is ln of 3. ln of e is 1, and so there's one of my solutions, ln of 3. What about this? E to the x plus 4 equals 0. E to the x equals negative 4. Take the ln on both sides, break this down. I get x equals ln of negative 4. Well, what's the problem with that? That's right. I can't take the ln of a negative number. In fact, I would have liked it if you got to this point where you were looking at e to the x equals negative 4 and said that can't happen. How do I know that? Well, let's think about this. The e to the x graph looks like this: 0, 1, 1, e, and negative 1, 1 over e. There's my e to the x. This is the horizontal line, y equals negative 4. Do they intersect? No, because there's a horizontal asymptote there. Yeah, this never goes below 0. Doesn't even get to 0. There's no way this exponential can equal negative 4. So if you don't catch it here, your next and last opportunity to catch is here, when you say, oh, I can't take the log of a negative number. All right? Okay. Yeah, the scary ones. 3 to the 2x minus 1 equals 5 to the 3 minus x. The bases aren't the same. Yep. But, I mean, you could take the log base 3 of both sides. And this side would be really happy and bring this down. Log base 3 of 3 is 1. But here, I'm not going to have the log base 3 of 3. I'm going to have the log base 3 of 5. Sad face. So, while I can do the log base 3 of both sides, I'm just going to do the ln of both sides. And bring this down, and bring this down. So I have 2x minus 1, ln of 3, equals 3 minus x, ln of 5. Really common mistake here is people don't put these parentheses, and they distribute this only to that. And they distribute this only to that. No, sorry, you've got to distribute. So we've got 2x ln 3 minus ln of 3 equals 3 ln of 5 minus x ln of 5. Okay, so I did some distributing. I'd like to get the x stuff all on one side. So I'm going to add x ln of 5 to both sides. And I want to get the stuff that doesn't have x's off this side. So now I'm going to have 3x, oh no, these aren't the same. Sorry. ln of 3 plus x ln of 5 equals 3 ln of 5 plus ln of 3. Okay, almost done. Notice how both of these terms have an x. Let's factor it out. So ln 3 plus ln 5. I need x by itself. How is all this stuff attached to that x? With multiplication. So I need to divide both sides. And so that's my answer. Again, exponential, could work. I don't really want to try and plug this into those places. If I really don't feel comfortable with this, I'd much rather graph this in y1, graph this in y2, second, calculate, intersect. Okay? All right, so your one, here we go, says 2 to the 1 minus 3x equals 3 to the 2 plus x. Will you please solve this equation? I do recommend, having seen that last problem, did you write stuff down in your notebook? Because look, you've got to do it again here. Okay. Okay. So, I'm going to take the ln of both sides. You could take the log base 2 of both sides, or you could take the log base 3 of both sides, and one of the sides is going to be really happy with you, and the other is not. So I'd rather just go with something that's a little less to write. I'm going to bring my powers down. 1 minus 3x times the ln of 2 equals 2 plus x times the ln of 3. Next comes the distributing. And so I'm going to have 1 times this minus this times this, minus 3x ln of 2. Over here, I distribute some more, 2 ln 3 plus x ln 3. I want to move all my x's to one side and all my not x's to the other. I'm going to move this over here this time. 3x ln of 2, 3x ln of 2. That will cancel those. I also want to move the not x stuff. Minus 2 ln of 3 onto the left side. So now I'm going to have 2, no I'm not. I'm going to have ln of 2 minus 2 ln of 3 equals, those went away, here, x ln of 3 plus 3x ln of 2. Good. Now what? Well, look, you've got two terms over here, and they have a common factor. What could you do? That's right, you could factor out that x. And over here, we still have ln of 2 minus 2 ln of 3. So to get x by itself, I need to divide both sides by ln of 3 plus 3 ln of 2. ln of 3 plus 3 ln of 2. There we go. That's my answer. And that's the last problem for today. Well, it was wonderful to see you all, except I didn't get to see you all, so that kind of sucked. But I'm glad you were here. Thanks for watching the video. And please let me know if there's anything I can do to help. Take care, everyone.